All right, 1-4, day 2. I'm kind of glad we chopped it up into 2. Here we go, bunch of trig coming at you. SOHCAHTOA. We're going to use these trig functions to find the missing length of these triangles. So here we go. Take a look at this. This is our reference angle. Go straight across. That means this is the opposite side. This is just the hypotenuse. I forgot to put that in there, but that's a 90-degree angle. So what trig function uses opposite and hypotenuse? That would be sine. So I'm going to go sine of 36 degrees equals opposite over hypotenuse. So I've got my handy dandy calculator right here. And I got to turn this into a number. Now make sure your calculator is in degree mode, not radians or gradians. So I'm going to go sine of 36 degrees, enter, 0.587. How accurate do you need to be? Well, let's just go to the thousandth, and then we'll go x over 12. Now it's just pure math. Multiply both sides by 12. 12, and let me get the calculator, times 12, 7.05. So 7.05 equals x. Move on to this one. Here's my reference angle. This is my opposite, which I'm not going to use. This is my hypotenuse. I'm going to use it. And this is my adjacent side. What trig function uses adjacent and hypotenuse? That'd be cosine. So now I'm going to go cosine of 47 degrees is my adjacent over my hypotenuse. This is a little different because the variable I'm trying to find is buried in the denominator, so you're going to have to use your algebra a little differently. First, let's find cosine of 47 degrees. Come on, eyeballs. 0.681. 0.681 equals 6 over x. Well, I got to get that out of the denominator, so I'm going to multiply by x, so it's gone. I got to multiply this side by x, so I get 0.681x equals 6. Divide by 0.681, divide by 0.681, and here we go. 6 divided by 0.681, 8.81. So there it is, 8.81. And we look at it, and yeah, the hypotenuse should be longer than that side, so we're feeling pretty good. So this one, here's my reference angle. I go straight across. That means this is my opposite. This is my hypotenuse, which I'm not going to use, but that makes this the adjacent side. So this time I'm going to use tangent. So the tangent of 43 degrees equals my opposite side over my adjacent. Let me look this up. Tangent of 43 degrees, 0.932. So that is 0.932 equals x over 12. This time, x is not in the denominator, so I just multiply this side by 12, multiply that side by 12, and here we go. 11.19. So 11.19 equals x. If somebody went 11.2, that's okay. The bottom line is, you know how to use the trig. All right, there's more coming. All right, so again, this whole first unit is kind of just all over the place. This has nothing to do with trig. This goes back to your just describing a function and finding what they're asking for. So g of x is equal to this, 2x squared minus 5x plus 3. We're saying find g of x plus 3. Now, if this was a 2, if it was a 2, you would simply put a 2 there, a 2 there, do the PEMDAS, and figure out what that number is, and that'd be your answer. But this, I'm changing it to x plus 3, which means wherever x is, I got to let x equal x plus 3. So, a little bit of an algebra nightmare, but they're doing this to you on purpose to see if you can hang tough. So in there, I need to go 2 times x plus 3 squared minus 5 times x. I got to take that out, replace it with x plus 3 plus 3. You see the algebra nightmare? Here comes a warning. 2 plus 3 squared. Now, if you follow good old PEMDAS, you get 5 squared, which is 25. If you tried something like this, watch, distribute, distribute, you get 2 squared plus 3 squared, which is 4 plus 9, which is 13, which sure isn't 25, which means you cannot distribute a power through a binomial if there's a plus or a minus. It just does not work. Why am I showing you that right now? Because I think somebody here would square this and square that and pat themselves on the back and go, look at me. Nope, you made a mistake. And it won't show itself like these numbers did. So what do? Well, when you square a binomial, you have to square a binomial. Now, I'm going to ignore this. I'm going to save that for last. I'm going to concentrate here. Here's my FOIL. So x times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. So I get x squared plus 6x plus 9, but don't forget this little 2 out here. So I distribute, distribute, distribute. I get 2x squared plus 12x plus 18. Just so you know, if you did decide to do this first, you could only multiply this by a 2 or this by a 2, but not both of them. If you multiply both of these by 2's, you'd be actually multiplying by 4, and you're going to get something totally different. So that's why I keep this for last. It's just kind of simple. So there's that. But now I got to distribute this negative 5 through there, so I get minus 5x minus 15, and then the plus 3 there. And now I look for like terms. 2x squared, that's gone. 12x minus 5x is 7x. 18 minus 15 is 3, plus 3 is 6. This equals that. So not hard, but there's a couple tricky things in there. All right, they're going to introduce you to some complex fractions and see how you can handle them. Just so you know, there's really 3 problems. There's problem number 1. There's problem number 2. And then this right here, this division problem, is actually problem number 3. So let's take care of the top. So problem number 1. 2/3 plus 1/4. We've got to find common denominator, so I'm going to multiply that by 4 over 4. So that's 8/12 plus, I'm going to multiply this by 3 over 3. So that'd be 3/12, which would be 11/12. That's my top answer. Now number 2, that's pretty simple. There's a couple ways of doing this, but I'm going to think of it as 3 1/3. And I'm going to turn this mixed number into an improper fraction. 3 times 3 is 9, plus 1 is 10. So I just get 10/3. Now, this problem actually turns into 11/12 over 10/3, which is the same thing as 11/12 divided by 10/3. So you got to know that this is the same thing as this. So this takes us back to what we're used to. The first fraction, or the top fraction, stays put. The second fraction, or the bottom, we flip it and multiply. So now we cross reduce. 3 goes into 12 4 times. And now we multiply straight across. It's 11 over 40. And that would be my answer for this complex fraction. Now, I would only show you one, but this one has a little twist in it. Some of you would think, hey, I'm just going to cross these out and make them ones, and you best be careful doing that, because look at it. Let's go 8 plus 2, I'm just making this up, 6 plus 2. Let's do our math. That'd be 10/8 which is 5/4. That is for sure the correct answer. But if somebody crossed these out and reduced 8/6, they'd get 4/3, which is not the same as 5/4. So this person did it wrong this way. So you cannot cross these out. You just can't. So there's your basic skills being challenged. It's tempting, but you can't. So how do I do this? Well, I'm going to go to a driver's ed rule and think of this as a double white. I know there's a purple one and a red one, but think of them as double white lines. You don't cross those. I know you're going to want to take this one maybe underneath, because 3 to the -1 power is definitely 1/3 to the first power. Some of you are going to want to take this down. But remember what I said over here. There's a problem in the top. That's problem number 1. There's a problem in the bottom. That's problem number 2. And then this is my final problem number 3, and that's divide. So let's take care of the top. 4 minus, now what did we say that was? 1/3. Now, you could look at this right now and go, aha, that's 3 2/3. You don't really need to find common denominators. You could. And then 3 times 3 is 9, plus 2 is 11/3. So that is the answer to the top. I'll do the same thing here. 7 plus 1/3. Well, that's just 7 1/3. 3 times 7 is 21, plus 1 is 22/3. Now, really, it's 11/3 over 22/3. So what do I do with the bottom? I flip it, and I multiply. So these cancel, and then 11 goes into 11 once, 11 goes into 22 twice. So then I multiply straight across, and I get a half. So there's that. There'll be a few of those on your homework. Now the author wants to take the time to remind you of your good friend, the quadratic formula, that will solve any trinomial. Yes, you could factor this. There's different ways to solve this, but the author wants you to be really familiar with the quadratic formula. So this is the same thing as ax squared plus bx plus c equals 0. So before you use the quadratic formula, you have to remember to set it equal to 0, which this one already is. Now, if it's not, then you got to take the time to set it all equal to 0. But now we know that a is 4, b is 3, c is -12. This is just plug and chug. This means take the opposite of whatever b is. So that's a +3, so it's -3 plus or minus the square root of b squared. So I'm going to square that, make it 9. -4 times a times c. Be careful of those negatives. All over, remember this goes all the way underneath all of this stuff. 2a, which would be 8. Now you just clean it up. -3 plus or minus the square root. Now these two negatives will make a positive. So 4 times 4, well, let's do it this way. That's 48 times 4. Come on, mental math. 48 times 4. I just don't want to screw it up. 9 plus 160 plus 32. 192. All over 8. So I add this together, and I would get -3 plus or minus the square root. That would be 201 all over 8. Now, the square root of 201, you can break that down. You should. Now, I'll throw this in for free today. If you can break this down, I'm saying if, and you get something like this, -3 plus or minus, I'm just making this up. I'm making it up. 6 square root of whatever, 7 all over 3, then these things could continue. You get -1 plus or minus 2 square root of 7. That's if you had this. But as you can see, there's a 1 here, 1/8, no, 3/8, no, square root of 201, you can't break that down. So you'd be done. And I think, yep, that finishes your lesson for 1-4 day 2.